Okay, tonight what we are going to be talking about are something called significant figures or significant digits. And these are an important concept that you will be seeing throughout the entire year. Okay? Scientists report measurements using the concept of sig figs or significant figures. Significant figures are the minimum number of digits needed without loss of accuracy. It is important to use sig figs when recording a measurement so that it does not appear to be more accurate than the equipment is capable of determining. Basically what I'm saying is it's how we round in science. Okay, and why we round. Sig figs also help us keep focused on the numbers that are actually important. This helps us as scientists maintain realistic expectations when doing measurements in an actual lab environment. For example, let's say you are measuring the driving distance from the middle of Washington, D.C. to the middle of Dallas, Texas. Any direction site will tell you that it's approximately 1,300 miles. Is the distance exactly 1,300 miles? Of course not. However, it is the part of the distance that we care about. The extra few feet, inches, and fractions of an inch are insignificant compared to the size of the mile. One key idea to remember when you're doing this is that, and the reason why we do that, this rounding is because it's not math class. We do something in science that math typically doesn't. We actually measure things, and during these measurements, we estimate. For example, if I took the mass of a penny and found it to be 2.51 grams, it would be inaccurate to assume that it was exactly 2.51000000000000 grams. The instrument or ourselves estimated that last digit. For this reason, we need to report our answers to reflect how accurate our measurements actually were, okay? Because we were taking measurements, and you need to report how accurate they were. So tonight what we're going to be talking about is how to count sig figs, how to round with sig figs, and how to do multiplication division with sig figs. The first step is to count significant figures. And what I'm going to tell you about is the PA system. And the PA system represents the Pacific and Atlantic normally. So where's the Pacific found? It is found on the left side or the west side of the United States. And where is it the Atlantic found? It is found on the East Coast. If you guys can't remember which side, I always think of Atlanta, Georgia is on the Atlantic side. So they kind of go together. Okay? But in this class, it doesn't stand for Atlantic or Pacific. It stands for whether a decimal is absent or present. Okay? So we're going to follow these exact 4 steps that you should be copying down. Okay? And if you didn't, you can pause it, copy them down in order to count the number of significant figures in the example. Okay? So the first one, we are going to need to identify if a decimal is present or not. Do you see a decimal? In this first one, I do not see a decimal, so therefore I am going to start from the Atlantic or the absent side, which is the right side. I'm going to go from that direction, because if I looked at the United States, I know this is really bad, but here's the Atlantic, here's the present or the Pacific, so mine is absent, so I'm going to start from the right side and work my way left, and if it was present, I'm going to start from the left side and work my way right. So in this one, I don't see one, so I'm going to start from the absent side, which is the right, and then I'm going to step 3 says start counting at the first non-zero number. A non-zero number is any number other than 0. So this guy right there, this is a 0, so I won't start counting. So I'm going to start counting at this 5, so it's 1, 2, 3, 4, 5. Because once you start counting, you keep counting until you run out of numbers. So this one would have 5 significant figures. Okay, the next example, I see a decimal present. Present will be from the left side because it will be from the Pacific side of the United States. So I'm always going to start from the left side for the present. I'm going to start counting at the first non-zero number. The first non-zero number is 3. So I'm going to, once I start counting, I'm going to keep counting until I run out of numbers. So it's 1, 2, 3, 4. So this would have 4 significant figures. Number 3, I do not see a decimal present, so I'm going to start from the Pacific or the right side, work my way left, inland. Okay, the first number that I see that is a non-zero number is that 3. I see no numbers after that, so therefore this would only have 1 significant figure. 1.5 times 10 to the 5th. For anything where you use scientific notation, you can ignore this. number when you are counting number of sig figs. So in this case I see 1.5, so that point does have a decimal. So I'm going to start from the left, work my way right, start counting at my first non-zero number, which is 1, keep going in that direction and keep counting till I run out of numbers. So this would have 2 sig figs. This last one, the decimal is present, so I'm going to still start from the left side going inward, and it is going to start at this 6 is my first non-zero number, so this would be 1, 2, 3, 4, 5. So this would have 5 significant figures. That is how you count sig figs. Most students don't have problems counting. What they do is they have problems rounding, okay? And these 5 rules you need to write down, okay, and become very, very familiar with, because you will be expected to round for the entire year, especially second semester when we use lots and lots and lots and lots and lots of numbers. So I'm just going to go through the steps with you with these things. What this stands for is this is the number, 135.35, and the 4SF says I'm telling you to round in these examples to 4 significant figures. Okay, so for this one we're going to round to 4 sig figs. So the first step is always start from the left when you're rounding. The second, so we're going to start from this direction, start counting at the first non-zero number. In this case, that would be that guy. Count to the correct number of sig figs. So I need to count to, this guy is saying that I need to do 4, so it's 1, 2, 3, 4. Okay, so I get up to that number 3. Number 4, as far as the rules go, is round that number. If that number is a 0 before the 1's position, which it is not, so I don't need to worry about that. Okay, so I'm going to round this number. How you round is you look at the number after it. So I'm going to look at the 5, and that would turn the number rounded up. So this would be 135.4. Okay, now I have to worry about that 5, and that comes in for step 5 on the rounding sig figs, which says for every number after the rounded position, which would be that 5, it is found after the decimal, so I just need to drop it. Okay, problem number 2. Same number, just 2 sig figs. So I'm always going to start from the left, start counting at the first non-zero number, so that would be 1, 2. Okay, we count to the correct number of sig figs. I need to round that number. This would also round up, so this would be 1, 4. Okay, we're going to need to now worry about these guys afterwards, though. What am I going to do to this? Now, this is just rounding, so you need to keep approximately the same number. This won't change. 135 won't change to 14. That's not even close to the same number. Okay, instead we need to round it so it's approximately the same number. If I look at rules for rounding with sig figs, step number 5, it says that the numbers before the decimal turn to 0. Well, this guy right here, this first 5, is a number before the decimal, so I'm going to turn it into a 0. Then it says if the numbers are after the decimal, which are represented by these 3, 5 right there, then you just drop them. So those would be gone. So 135.35 rounded to 2 significant figures, or 2 sig figs, would round to 140. Next one, 3 sig figs. For this one, you're going to ignore when you're counting the sig figs, this guy, the exponent, but you are going to need to include it in the number because it does give value to the number. It just is not a significant as far as your measurements go for that part. Okay, so we're going to start with the rules. Once again, 3 sig figs, always start from the left. So we're going to start from the left, start counting at the first non-zero, 1, 2, 3. Okay, we're going to look at that number. So it's going to round up because of the 6, so it would turn to 1.51. Now I have to worry about that 6. The 6 is found after that decimal, so therefore you drop it. So it would turn to 1.51. As I stated before, though, you are going to need to carry over that times 10 to the 4th number. All right, now we need to round this guy to 2 sig figs. So we're going to always start from the left, and we are going to start counting at the first non-zero number, which I'm going to skip these 2 zeros, and I'm going to count that 6. Okay, I need to count to 2, so it would be 1, 2. The 5 is the number that I'm going to round. I'm going to look at that 9, which means that it would round up. So I'm going to repeat everything up to that rounded number. I'm going to rewrite, so it's 0.06. That 5 will round up to a 6. These numbers after that 5 are found after the decimal, so they will drop off. So you end up with 0.066. Next one, we are going to round to 3 significant figures. So we're always going to start from the left, and we're going to count to 3, starting at the 5 because it's the first non-zero number. So it's 1, 2, 3. That number is going to stay the same because the number after it is a 3, so it will not round up. So it would be 5.80. These guys, the 3, 5, 4, are found after the decimal right here, so therefore they drop off. So I would end up with 5.80. This is the weirdo, okay? And this is the, I need to round to 2 sig figs. So it's 1, 2, because once again, you always start from the left, work your way right. Okay, so I need to count to the correct number of sig figs, which is that one. Step 4 says round that number if that number is a 0 before the ones position. Well, this number that I'm trying to round is a 0 and it's before the ones position, which is right there. Then I need to turn it into scientific notation and then round the number. So I'm going to need to turn this guy into scientific notation. In order to do that, we're going to go back and remember what we learned in the scientific notation video. Move it over 1, 2. So this in scientific notation would be 1.00 times 10 to the second. And now I'm going to round this number, the 1.00 times 10 to the second, to 2 sig figs. So I'm going to start my way on the left, start counting at the first non-zero number, which is this guy, 1, 2. Now I look at that number. It will not round up because the number next to it is a 0. So this would be 1.0. This second 0 right here is after the decimal, so it is going to drop off. So we end up with 1.0, and remember, you need to carry that times 10 to the second down. Okay, you always maintain that. So that's how you round sig figs. The last thing is how, when you're doing a multiplication or division, is how to round, how many you know to round to. As you look in the previous examples, I told you how many sig figs to round to. But when you look at any other example that you're going to be doing in class, I'm not going to tell you how many sig figs. Okay? So you're going to follow these steps in order to learn how to round to the sig figs. So the first thing is that you're going to find out the sig figs for all of them. That should be find out this should be a number. Instead of 3, it should be the number of sig figs for all the numbers. Okay, so the first step is find out the number of sig figs for all the numbers. So if I look at this guy of 4.501, I am going to count. I see a decimal present, so I'm going to start from the Pacific side, which means I start at the first non-zero, so it's 1, 2, 3, 4. So this would have 4 sig figs. The 0.01, I would start because the decimal present. I would still start from the left, going to the right, but I'd start at the first non-zero, which is that 1. So this would have 1 sig fig. So 4.501 has 4 sig figs. 0.01 has 1 sig fig. So that would be step number 1. Step number 2 says round to the lowest number of sig figs. Well, 4 versus 1, 1 is a lower number, so I would have to round my answer to 1 sig figs. All right, next one, B. So whatever I would plug it into my calculator and then round that number to 1 sig fig. This guy, B, let's count all the sig figs. So 10.005, be 1, 2, because it's present, 1, 2, 3, 4, 5. So this is 5 sig figs. 0.0458 would start at the 4, so that'd be 1, 2, 3. So that'd have 3 sig figs. And when we compare 5 versus 3, 3 is the smaller number, so this answer, whatever it has, whatever it would be, would have to be rounded to 3 sig figs. All right, tonight you learned about sig figs, you learned about how to count them, how to round them, and then how to round when you actually have a calculation for multiplication and division. Have a great night.